Hello, I am Brock Stanton. I'm an aspiring meteorologist, and today we are going to be taking a look at this enhanced risk across portions of Oklahoma, Kansas, Missouri, and even extreme northwest Arkansas. And then we're also going to be taking a brief look at these day 3 and day 4 risks, which you can actually see we have a day 4 enhanced risk. That's actually a pretty rare outlook. You don't see too many of those each year. You see some, but not too many of them. But just a better breakdown of this day 2 risk, you can see we have this 10% significant for tornadoes. So we could be looking at a tornado outbreak tomorrow across portions of southern Kansas through perhaps down into the Oklahoma City metro area. Though I will say, once you get much farther south of the Oklahoma City, Kansas border, the threat becomes much more uncertain because there is going to be still a little bit of convective inhibition or a capping inversion. And it's not going to be too strong of a capping inversion. It's going to be pretty weak. But a lot of models are not suggesting storms will fire in that environment. However, if they do, the environment is going to be extremely favorable for large hail damaging winds and tornadoes. It's going to be a very primed environment, especially as we get into the late evening hours as the low level shear will ramp up. But there's also this 30% wind outlook as storms organize into clusters into the evening hours. I would not rule out with seeing a significant upgrade to that, but regardless, that's an area of potentially widespread damaging winds, so still very important. And then here, where the mode is expected to be mainly supercells, we're going to see there's that significant for chance of hail greater than 2 inches or larger. And we're going to take a look at our HRRR first, and here we need to switch back to our 18 seats, trying to put me on the 12Z and try and mess up my video, but we're not going to let that happen today. You can see this is some hail event that's ongoing right now. It's ongoing further south as well, but pretty significant hail event across portions of West Texas and eastern New Mexico today, I will say. So we're going to see here as we move into the afternoon, the HRRR fires these discrete to semi-discrete supercells, and some models have these storms a little bit more clustered. Some of these models do keep the storms a little bit more clustered. However, any storms, especially the ones riding the border, because these storms up here are likely elevated, so they would mostly carry a risk for very large hail. But these storms right along the border here, they have a greater chance of being surface-based, which means, given the fact that they're going to be riding the boundary between colder and warmer air, that would suggest an increased tornado potential right along that boundary. So you can see they're going to move east across the northern area of the 10% significant area, and that's probably the area of highest confidence of severe weather with this outlook. Probably the greatest chance of seeing significant hazards possible. We're just going to take a look at our surface-based CAPE for that, but again, I will say, I didn't think I showed this all the way through. Now this northern area, again, it will have it has the highest confidence of seeing severe weather, and the storms don't fire further south until the cold front arrives. However, we're just going to take a sounding here, 23Z, central Oklahoma. We're going to see there's basically no capping inversion in place here. See, there's just a teeny tiny bit of a temperature inversion aloft. It's an incredibly weak cap. It would seem more likely than not that storms would initiate along this dry line, and that could carry the risk of very large hail and strong tornadoes, as well as winds. Though that mode, not many of the models are initiating that mode despite the weak cap, so then they'll fire these storms in the overnight, and that will carry a risk of damaging winds. So we're just going to have to watch that and see how it develops, because the environment, assuming a storm develops in, is very favorable for significant hazards. So we're just gonna have to keep an eye on that and see how that capping inversion holds. Maybe hopefully it's a little stronger than what the models are indicating, because what the models are what they're currently showing, I'm not confident that I think storms would likely initiate it, at least in very isolated areas. You can see our mixed layer CAPE here. We can see how these storms are kind of riding right along the border of that greater CAPE, or not. But remember the storms we saw up here? They don't really have much CAPE to work with, and they're likely going to be elevated because of that. Again, mostly a hail risk. But we can see how as we get into this further south area across central Oklahoma, by 0Z, there's going to be a very favorable thermodynamic and shear environment. Again, a pretty weak capping inversion in place. That capping inversion could hold, it may or may not hold, and that's really across central Oklahoma. That's going to be the huge difference maker. Very similar to the event we had a couple of days ago in that, the overall system's a little bit different, but in that it all is going to come down to the capping inversion because, the environment a couple of days ago, I believe it was Friday night, if I'm correct. Yeah, Friday night, there was an enhanced risk out for portions of Oklahoma, and then storms just didn't fire, so there was no severe weather, but storms came very close to breaking that cap. So it's going to be a very similar in that it's just going to come down to these storms breaking through the capping inversion, and if they do, then they're going to be very capable of all severe weather hazards. And you can just see here this is peak heating, 4 o'clock Central Time, there's basically no cap in place on the HRRR. So that very much so concerns me because if we have our dry line here, which we're going to show for forcing, let's see, this only shows low level forcing, by the way. But we can see by 21Z, we have a dry line here in place, and we're just going to take a sounding just east of it. I think this is a little farther west, but if there's basically no cap in base and we're going to have our convergence there, that could help to fire storms in a very moist environment, by the way. I do think these 70 dew points may be a bit ambitious by the HRRR, but regardless, there's going to be a very moist environment, strong thermodynamics, and increasing shear through the evening and overnight hours. So, again, especially in that central Oklahoma, it's just going to come down to the capping inversion. I wish I could tell you whether that capping inversion is going to break 100%. I lean towards the fact that it's going to break. It's just so weak, but you also need enough forcing to be able to break through that, and we're not quite sure that dry line is going to provide just enough to be able to break through it. So we are going to take a look at our surface-based Cape photograph overlap, to kind of show you how that shear environment does play out, overlapping with our instability. And we can see how as we get into the peaking here, look at this. This model is outputting surface-based Cape well over 4,000 here across portions of west central Oklahoma. And then these long curved photographs. Again, this is just going to be a very favorable environment for tornadoes if they develop. Here the capping inversion is a little bit stronger, so hopefully that's a little more widespread and that's able to hold, but there's potential for very significant severe weather here across a large portion of central Oklahoma. And now we're taking a look at our storm relative helicity values, and we can see here how we look for values around 150, we can see they're around there by 21Z, 22Z, that's 4 or 5 o'clock. But really, as we increase towards 6 and 7 o'clock, they're really going to begin to ramp up more. So then by here, we don't want that sounding, but by 0Z, we have our 0 to 1 storm relative helicity values well over 200. That's supportive of strong tornadoes. We can already see that our thermodynamic environment is going to be there. And then our 0 to 3 storm relative velocity values are also going to be quite favorable. We're going to see how, again, by 0Z, these are going to be well over 300, perhaps even over 400 or over 450. So it's an incredibly unfavorable environment for tornadoes, but it's just so conditional upon a storm forming in that environment. And I do think there's a good chance we see at least 1 or 2 storms form down there, but the coverage of that area is just a little bit uncertain still. It's actually more than a little bit, very uncertain. We're going to take a look at our 850 jet quick before we move on to our NAM. And we're going to see how it's still decently strong during the afternoon hours. This is 4 o'clock Central Time, generally 30 to 40 knots. But as we increase, this is by 0Z, 7 o'clock, we can see generally 40, 45 knots here. So that's going to be supportive of our potentially strong tornado threat. Again, it's just so conditional upon this capping inversion breaking and storms forming. But if they do break through, again, it's just going to be, it's so uncertain. But that's really what this severe weather event is going to come down to for portions of central Oklahoma. And if storms do break through that cap, I do think we'll be dealing with a tornado outbreak, just because most of the other ingredients are there for it. But we are switching to our NAM now. We're going to see again that it's our big hail event ongoing right now across portions of West Texas. Will eventually spread east. Some portions of Oklahoma could see some severe weather into the overnight hours, but not as significant hazards. But we can see our NAM here. It does fire these storms, and it brings them. NAM does fire these storms. It fires them a little more linear, and I'm just going to check and see if this is along the dry line, because if this is along the dry line and not the cold front, I would think this would be a more supercellular mode. And yeah, that seems to be along the dry line. We're going to take the temperatures just to confirm that. Yeah, look, see our warm fronts up here, our cold fronts surging back there. So that looks to be mostly dry line storms forming there. So it would not surprise me if the NAM is showing a lot more linear than what this mode would be if it does develop. And I will say, so the NAM has a bias towards more lines of storms. ARRR has a bias towards showing more supercells. That's part of the reason why I know the ARRR showed like 4 supercells across southern Kansas. It might end up being a little more mixed mode just because that's what the ARRR has a bias towards showing more supercells. But we can see here these storms do develop, and again, we'll just take a look at 0Z here ahead of these storms. We're going to see that turning in the hodograph, and the cap does break. See, there's still a weak cap and break, but the storms are breaking through that, and again, you can see that there's our capping inversion there, but we have storms ongoing in the sounding, and the turning in the hodograph are very favorable cape, pretty good lapse rates. Again, this would support all hazards. We just need to figure out exactly if storms will end up developing in this environment, and if so, to what extent. So again, we do see that NAM does form storms in this environment, but we do want to take a look at our mixed layer capping inversion, and we can see that it is a little bit stronger in the NAM. So now I think the NAM probably has some stronger forcing because it breaks through this cap while the ARRR doesn't. But this capping inversion, despite the NAM firing storms, is actually a little bit stronger than what the ARRR shows. That's kind of a little bit weird. It's probably the likely reason that there's a difference in that is the amount of mid and upper level forcing is likely what's causing the difference in those, stronger capping inversion but more storms and weaker capping inversion but less storms. So that's likely what's causing that, is the difference in mid and upper level forcing. But we are going to take a look at our 850 jet now, and we're going to see how the NAM, we'll go to 0Z here, and it feels like as the Royal jet perhaps a bit further, has it not quite as expansive, but overall, as far as storm coverage goes, it's basically the exact same area, pretty similar in strength, around 40-45 knots. So there's a pretty good confidence in the most part of the environment that's going to be coming together for this. And again, we're going to take a look at our cape. So as we're taking a look at the instability here on the NAM 3K, we're going to see how the instability is basically going to ride. The northern extent of it is probably going to be just north of the Oklahoma-Kansas border. For that, that's going to be there, and point south is going to be where our greatest severe weather risk will be. And so let's just take a sounding here on this northern mode and just see what it looks like. You can see, so this is actually saying a strong tornado would be possible, which if we get a discrete supercell, I would mostly agree with. We can see this hodograph. It's not the largest hodograph in the world. You want a long looping hodograph. This hodograph certainly has the looping aspect of it, but it's not quite as long as you would want to see for a strong tornado, but still strong cape, very good helicity values, would still support a tornado threat, absolutely, with that. And then further south, I know we talked about there being a little more of a capping inversion, but on the NAM 3K, but if a storm did form, it would be capable of all hazards and significant hazards at that. We're going to take a look at our bulk shear quickly, and we're going to see how it's going to be sufficient really across the entire risk area to organize these storms into supercells. Bulk shear is not going to be an issue with the setup. Very similar picture on the ARRR. Now we're going to take a look at our storm relative helicity values. And we're going to see how again, they're really going to increase in the NAM shows a little bit of a different picture here, actually. It shows them not increasing quite as much. I'm kind of just holding steady, but that's still going to be sufficient for tornadoes here, our 0 to 1 level. And then when we look at our 0 to 3 level, yeah, they're going to be even more favorable. So still, our storm relative helicity values are still supportive of strong tornadoes here. Again, with southern extent, convective initiation becomes a lot more uncertain, but I do tend to think we will see at least a storm or two form in that environment. And we're going to take a look at some of these other models, and I will say, I know I said in my intro that we're going to be looking at these on a couple other risk days, so I've had to pause this recording a couple of different times, so it's a lot later than what you're going to be seeing in the time thing. I don't think I'm going to have time to get to that, unfortunately, so we're just going to, it would be like super quickly going over, and I just wouldn't really have time to, so instead we'll take a look at these other models instead, and tomorrow, hopefully I'll be able to update you on the risks. That's the day 3 and day 4 risk, but by then it will be the day 2 and 3 risk, so hopefully I'll be able to give you a better update on that tomorrow. You can see our moisture on this model. It's not going to be quite as strong as the other models, but still we can see mid to perhaps upper 60s dew points here. In this storm, it looks like it kind of hints at breaking the capping inversion a little bit, just based off what it shows there. Let's see. As we get into the day, yeah, we can see, look, this storm breaks the cap further south. You can see here, it's around, well, that's in or just north of the Oklahoma City metro area. You can see here that it's a pretty favorable turning hodograph. We have our 80 over 64 for our temperature dew point spread, no capping inversions. That's a pretty favorable sounding for severe weather and tornadoes there. I know I only said severe, but that would not surprise me if there's a tornado with a sounding like that, if that were to verify. And we're just going to take a look at our surface-based CAPE and hodograph overlap. Nice little blend of everything, in my opinion. And we can see how really by we get close to 0Z, again, that 0Z is 7 o'clock Central Time, these hodographs begin to elongate a lot more and turn. So again, any discrete supercell we have, the later we get into the evening, the more significant the tornado risk will become. And we're just going to take a look at another model here, just quick look at it. We're going to take a look at the capping inversion on this first before we take a look at the reflectivity output. And we're going to see how this basically completely erodes the cap here. Curious on what the environment is like in this area with the stronger cap. So, yeah, so it seems like in this model, it shows a less of a cap further east of the dry line, but right along the dry line, it keeps that environment capped. And that looks like that's probably because on this model, it's not as tight of a dry line. So, that's likely what's causing the capping to be greater there in that sounding. We're going to take a look at our CAPE hodograph overlap, and again, this model, I doubt it ends up showing convective initiation because of that capping inversion west. Again, it'll show convective initiation in this further north mode, but further south, I doubt it does. But we can still see how those hodographs turn a lot more. We are going to take a look at the reflectivity output quickly for this. And we're going to see, again, these storms, perhaps some supercells at points, but again, these storms will probably eventually grow upscale. Exactly when that occurs is a little bit unclear for this northern mode, but they will eventually probably grow upscale into a squall line, and then that will eventually build back southwest as the cold front approaches. And especially across the peak of that blowing segment, I do see the possibility for some wind gusts, 70, 80 miles per hour. So we'll just have to keep an eye on that, but I do think there could be a few instances of significant wind gusts with that line, and then still some embedded tornadoes would be possible. Just, it wouldn't be quite as high of a risk compared to having discrete supercells. And with our final model here, the FV3, you're going to see how it seems like it develops not as much instability here. I wonder if it has those early morning showers limiting instability a little bit. And this model does again hold that little bit stronger of a capping inversion. Not a super strong capping inversion, it seems. We're just going to double check this here. So it increases it some by 0Z, but by 21Z here, we're going to see that there's basically no cap in place. This one, it seems like it increases the convective inhibition a little more into the evening hours, but still by peak heating it erodes that cap. So it would not surprise me if storms fire here. And they don't really build too far southwest, but again, I do still think that severe thunderstorm initiation along this dry line here and here to the central Oklahoma does still appear possible to likely maybe like a 60% chance of getting at least one storm to form along that dry line, one or two storms to form along that dry line, and really any storm that did form would be capable of producing a strong tornado. We're going to take a really quick look at our day 2 risk, and then we're not even going to bother looking at our day. We're going to take a quick look at our day 3 risk. Sorry about that. We're going to take a look at our day 3 risk, and we're not going to bother to take a look at our day 4 risk. I just don't have enough time, but we can at least take a quick look at this day 3 risk here. We're going to see, and we're only really going to take a look at the NAM because I just don't have enough time. We have to go to 18Z run, and we're going to see that it looks like there might be these showers early on in the day, but enough instability should develop in the wake of this that we do see these storms develop, scattered in nature, perhaps maybe a supercell or two if there's enough bulk shear. We're going to take a look at that in a second. Yeah, maybe some supercell storms, clusters, probably a mixed mode, but at least the NAM seems to try and fire a quarter of enough cape. I think it would be a little bit of a more narrow axis of cape just based off those early morning showers. Maybe not quite as much as I thought, but we can see here this axis of cape is going to develop. And again, an isolated tornado threat does seem possible with this just based off the soundings I'm seeing. We're going to take a look at our 850 jet as well and just see how powerful that is. And it doesn't seem to be too strong, especially with southern extent across Missouri and Arkansas and Tennessee. It doesn't seem quite as strong. Maybe areas a little further north, it was supportive of a tornado threat, but really once you get down further southwest, it just doesn't become that supportive of a tornado risk. You can see there's a blend of cape and shear, and you can see how with the greater shear values up north we still have favorable values, but then further to the southwest, we also have favorable values where there's greater cape. So again, overall pretty similar values, and that's just because the amount of cape and shear, they're kind of canceling each other off more or less. That's really all I have time for. I have to do some other stuff this evening before I get ready for school tomorrow, so I hope you enjoyed. Please consider liking and subscribing. I'm going to plug my Twitter down in the description. I've been very active on that because of the hail event in Texas today. But yeah, so I'll give you an update on the upcoming severe weather tomorrow. But until then, bye.